السلام عليكم قتابیان چۆنە نەحواڵتان هیوادارم زۆر باش بن لە هەر شوێنێکی ئەو کوردستانە ئازیز و خۆشەویستن سڵاوتان لێبێ هیوای تەندروستێکی باش و ورێکی پۆڵین و بەرزتانە بۆ دەخوازم بابین بابەتەکان تەواوکەین لە چاپتەری چوارم ئەوڕۆ باسی enthalpy of formation دەکەین inshallah if we have enough time we will dive into enthalpy of combustion also. Enthalpy of formation, last time I said it's symbolized by delta HF, enthalpy of formation. First of all, these are some strange phrases. First, you should learn the main point, which is the formation reaction. Then we'll get back to the whole descriptions. So stay with me. Okay, how to write the formation reaction? How to write the formation reaction. By the way, I'm not حازم ليه بيتجي بداية كان هم capital بس محل لو خون بخش هون. First of all, formation reaction it means product. Means what? Product. Okay, the standard mole is 1 mole. 1 mole of the product, and this is only for the compound. Mister. Formation reaction, it's for the compound, 1 mole at the product. So the rule is, you need to have 1 mole of the compound. 1 mole of the compound at the product side, and here we need to have the elements. Not the compound here. Let me write down this. Not compound, please. Kaka. Not compound. اقدر به ها کره لبو فرمیشنی به هیچ نوع اجنبی compound من لیره هبی. We only need the elements. Only the elements, please. يلا. بابين هذا بسيار الحل كان دي بابين. Question. Look. Write the formation reaction for the following substances. The first one, CH4. As I said, try to have the compound at the product side by 1 mole. 1 mole of CH4 here. Nice. Then the elements. How many elements are there? Carbon and hydrogen. Carbon and hydrogen. But Mr. لپولیازش لبیرما شتكت بيغوت بوين لسروي غوتت اگر هاتو we have something which is called diatomic molecules. Diatomic. What are the diatomic molecules? We have 7 of them. Hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, iodine. If we have them in their free form, they must be written as the diatomic molecules. Like this. So hydrogen must be 2. So on formation reaction ibn again, 1 mole of the compound must be written at the product side. By the reactants, you need to have the elements, not the compound. Kaka, not compound. Then try to balance the equation. 1 carbon, 4 hydrogens, multiply this by 2. Done. With my signature. Another one, second one. No, it's a book. C2H5OH. Ethanol. Then, again, write 1 mole of the compound at the product side. C2H5OH. 1 mole. Never change this, please. What are the elements? We have carbon plus hydrogen plus by oxygen. Good? Then balanced. But Mister, look, we have 2 diatomic molecules. Yeah, right. 2, 2. Get. O must be 2. Hydrogen must be 2. Then try to balance the whole equation. Start from the carbon, first one. Carbon is 2. Multiply this by 2. Then second one, start with hydrogen. We have 5 hydrogens with 1 of this. COH حيوان ببابي من OH nearly a good man nabi compound to be a element by element. Hydrogen 5 here with 1, 6. This is 2 times by 3. Oxygen is 1, here is 2. Okay, multiply this by 2. No. Don't change anything related to the compound. This is a solid fixed rule. Fixed rule. So instead of duplicating the compound, try to decrease this to half. 1 over 2. The last one. Look at it. CH3OH. Then write 1 mole of the compound at the product side. 1 mole CH3OH has been produced from the elements carbon, hydrogen, and the oxygen. 2, 2. Carbon 1 by 1. Good. Hydrogen 3 with 1, 4. This is 2 times 2, 4. Then oxygen here is 1. Here we have only 2. We have 2 oxygens, so multiply this by 1 over 2. Good. This is called formation equation. Our TP formation equation. These are formation equations. Look, how do we know if the equation is a formation? First of all, we need to have 1 mole of the compound. At the reactants, there must be elements alone. The amount of energy that is released or absorbed during the following equations is called delta HF, heat of formation. Heat of formation. ده يبقى تمشاكن ها؟ تمشاكا بابي من؟ These are formation equations. أنا هميان تيام بيدلين formation equation. How do you know if it's formation? Mister, look, we have 1 mole of the compound with the elements at the reactant side, of course. The amount of energy that is released or absorbed, okay, I will say transfer, during the following equations is called delta HF. Babin piras kan bukhino esta day. Enthalpy of formation is symbolized by delta HF. Is the enthalpy change, Mister? Delta HF is delta H. Enthalpy change يعني C. Let me tell you, last time I said one of the names of delta H is enthalpy change. It means delta HF is delta H. That means delta HF equals to delta H. Okay? Is the amount of delta HF is delta H when 1 mole of the compound is formed from its elements. From its elements. يعني ما مستعب بكرديكي خوما كرتي بيكلك لهمو او equation انا delta HF يكسانه بدلتا H. اوكي؟ يكسانه بتي delta HF. delta H delta HF. كات اجا بسيارة بين delta HF تيا. Enthalpy of formation is the enthalpy change. Is what? Enthalpy change during the formation reaction. أي formation reactions here, 1 mole of the compound from its elements. Done. تمشى كليرة عندك notes man here. تمشى. نالا تمشى مكة. عليرة تمشى مزانا. So we will compare the enthalpy of formation at a standard temperature to be meaningful, to have the correct comparison between them. Look, the standard state of water is liquid. Design أو standard state liquid ها أرسل كافية وأونية بلام standard liquid. با شبابي من? I'm sorry, I need to have a sip. Then at the standard state iron is solid. Iron معناه standard state is solid. نه gas نه liquid. نظام كانت بمعلوماتي دي ولا مو يكتب بس يدك. It's not a molten liquid. هو سبارة formation, yeah. السباسي يدك stability and enthalpy of formation. So what's the relation between the stability and enthalpy of formation? First of all, enthalpy of formation is symbolized by delta HF, okay? And it's only for the compound. It's for what? It's for the compound. It can be positive value, 0, and negative value. 0, it's for the elements. So enthalpy of formation for the elements is 0 only. We have some special cases. If it's positive, the compound is unstable. If it's negative, the compound is stable. If a large amount of energy as heat is released, it means negative. It's exo. Okay, exo results a stable compound. Look, when a compound is formed, the compound that has large negative enthalpy of formation, such a compounds are very stable. So it means compound with negative value of delta HF must be stable compared to the other, which are positive value. Good. And for the elements, enthalpy of formation is 0. Assume we have a question like this. Okay? This is a compound, delta HF must be given, delta HF equals to negative 393. But for the elements, you should know they have 0 value of delta HF. So delta HF here is 0, for this one is 0. Good. So now the point is, this is delta HF. Okay, delta HF can be 0, can be positive, and can be what? Negative. Okay. If it's positive, the compound is unstable. If it's negative, the compound is stable. And as much as the negativity is increased, stability is increased. But for this, as the positivity is increased, the instability or stability is decreased. Good. How about 0? 0 compared to the negative value, negative is stable, 0 must be unstable. 0 compared to the positive value, positive is unstable, so 0 must be stable. Compared to this. Wow, it's easy, I think. Now, this one, it has a negative value of delta HF. Delta HF equals to negative 393. But for these two, delta HF is 0. 0 compared to negative is unstable. So these two are unstable compared to this. This is more stable. Therefore, carbon dioxide is more stable than the elements by the value of its delta HF. And compounds with relatively positive value of enthalpy of formation or slightly negative, such a compound must be unstable. هذه خوبة جديدة زان ستلم من يا عسانة بابتك كزور بابي من ورا we have these 3 examples تمشى كده يقول له باخ أقعد ببابي من سيكا we have 3 examples ورا لقل منها وكان لبركة. The first one, acetylene ethine. The second one, mercury fulminate. تيمانها mercury fulminate. The third one, hydrogen iodide. Hydrogen iodide. See? Hydrogen iodide. For these 3 compounds, delta HF must be positive. Okay, not must be, it's positive. Delta HF is positive. And elements are 0. Elements are 0. Delta HF, of course. That means elements are more stable compared to the compounds. Look, in these 3 examples, the elements are more stable since they have 0 value of delta HF than the compound. The compound is positive value. It has positive value of delta HF. Okay? Yalla, let's have any of them with a nice detail. The first one, ethine, we'll get back to this in chapter 9. Of course, this is an alkyne. This is ethine carbon with triple bond. Carbon, carbon, hydrogen, hydrogen. Good. Ethine, the value of delta HF is positive. Okay, you don't need the number. Just know if it's positive or negative, it's positive. It reacts violently with water. It means strongly, rapidly with water. Rapidly react with oxygen. I'm sorry, of course, with oxygen. Okay, so acetylene is it can react violently, rapidly with oxygen. Therefore, we have to prevent its contact with oxygen. So it must be stored in cylinders as a solution in acetone. That means we will have a cylinder like this. There we will put acetone here. See the acetone. And next, we will dissolve ethine here. Okay? So this is used to store ethine, which is a solution. So ethine is stored in acetone as a solution. Why? Because we should prevent its contact with oxygen. Since it has a positive value of delta HF, so it will react with oxygen rapidly, violently. The first one. The second one, mercury fulminate. Let's learn how to write down the formula of mercury fulminate. Look, KNO. KNO. Okay? 2, 2, 2. Then add Hg. This is mercury fulminate. Again. KNO. KNO. 2, 2, 2. Add mercury. This is mercury fulminate. Okay? Mercury fulminate. Again, it has a positive value of delta HF. So it's unstable. That's why it's used as a detonator for the explosives. وكو detonator بكار sparky پیدا دكار لتقينوي. باشا لبري it's a very unstable substance because of its large value of delta HF. The last one, hydrogen iodide. This is hydrogen iodide, HI. Our reaction بنسو عاقل ب HI here. It's a colorless gas. Colorless gas. Ranginium. But at room temperature, it will decompose. It will what? Decompose to form I2 plus H2. I2 has a violet color. Violet color. So بسيارك دزاني شلون بابي من ضلي أما كاك بدايات سلندرك معناها بو أوها HI تدابوا T تدابوا HI تدابوا بو شوازي which is a colorless gas T بوا colorless بوا but I'm la purda binin rangi bought a violet suddenly suddenly HI changes to a violet gas. Why? Because it has a positive value of delta HF, so it's unstable. It will decompose at room temperature to form a violet I2. That's why HI colorless changes to a violet gas, because it has a positive value of delta HF, so it's unstable, it's a reactive substance, it will decompose at room temperature to release I2 gas, which is a violet gas. That's all. Ethine acetylene must be stored in cylinders as solution in acetone. Why? Because it's more stable now. It's a very unstable substance. Why? It's not stable. Reacts violently with oxygen, yep, correct. Highly unstable, yep. BC is correct. Those compounds with high negative value, negative enthalpy, it means stable. So such a compound must be more stable. Dominion, enthalpy of combustion دي اوش بعضا كم بابي من دي بيتعقد ما باوش لو باس كم دي دي بابي من باوش تان لو باس كم enthalpy of combustion. Believe me, these two reactions, combustion reaction and formation reaction, are extremely important to solve questions in chapter 4. Without them, you're gonna face a very big problem. But with them, all the problems are like this. Okay? So why don't you destroy the problems right now with me? Try to learn writing how to write try to learn the writing equation. Okay? This will be a very good point for you, will be your strength point against chapter 4. I know most of the students, they are afraid of chapter 4. All the times they say, Mr. This is the hardest chapter. Chapter 4 is the hardest chapter, the most confusing. You know why? One of the points is they don't know how to write the formation, the combustion reaction. What is the difference between them? Okay? How do we know if the reaction is formation or combustion? They don't know that kind of things. But if you learn them, you know chapter 4 will be like the other chapters, which are very easy. Okay? So it's time for the combustion reaction. How to write the combustion reaction? Okay, first of all, combustion reaction. Get. Combustion, it means combination with oxygen. Get. Assume we have X, Y, Z compound or substance plus O2. So combustion, it means combination of the ingredients or the atoms with oxygen. The beta XO plus ZO plus YO. Okay? Example, we have something like carbon, hydrogen, okay, and nitrogen and sulfur. Combining them with oxygen results what? Look, carbon with oxygen results CO2 plus hydrogen with oxygen results H2O. You should know this. Nitrogen with oxygen results NO2. And combination of sulfur with oxygen produces SO2. For you, we only have these four combinations: carbon, hydrogen, sulfur, nitrogen, plus O2, plus O2, plus O2, plus O2. To form what? CO2. To form H2O, to form SO2, and to form NO2. Done. How to write the combustion reaction? How to write the combustion reaction? Okay, first of all, you need to have 1 mole of the substance. What? The substance can be element or compound. This is for the combustion. 1 mole of the substance plus enough O2 to form the oxides. This is called the combustion reaction. يلا بعمل سمسيارة حلكة. Okay? ده بعمل. Question. Write the combustion reaction for the following substances. The first one, CH4. Okay. 1 mole of CH4 here, plus what? Plus O2. There. We have 2 different elements here, carbon and hydrogen. Carbon plus O2, CO2, plus hydrogen is H2O. That means each time when we have hydrogen and carbon plus O2, the products are CO2 and H2O. Priority to balance the combustion reaction. First one, start with carbon. Second one, hydrogen. The last one is the oxygen. Okay. Carbon 1, 1. Hydrogen, we have 4 hydrogens here, but here 2. Multiply this by 2. Good? Carbon, hydrogen. How about balancing oxygen? I know this is a very classic technique, but it's a very easy technique. So why don't you use it? How to balance oxygen? Underline this only. Ignore this. Underline the combustible substance. This is called combustible substance. And underline the whole products. Yalla. How many oxygens are there here? 0. About this, we have 2 oxygens here plus 1 times 2, 2 oxygens. Total is 4. That means count the total oxygens for the products with the oxygen inside of the combustible substance. Then you need to have a fraction, total oxygen for the product minus oxygen in the combustible substance equals to 4 over 2 equals to 2. Add this number to here. This is balanced. Our CP combustion reaction. Another one. The second example. C2H5OH. Okay. They take 1 mole of the substance at the reactant site. 1 mole of C2H5OH. Plus what? Plus O2. Get. What are the products? As I said, CO2 and the H2O. Get. How to balance? Start with carbon. 2 carbons here. We have 1 times this. Times this by 2. Get. Hydrogen. Look. 5 hydrogens here plus 1, 6. But here we have 2. Multiply this by 3. Then underline the combustible substance. There's only 1 oxygen here. 10 oxygen here. 1 oxygen. How about this? Look. 2 times 2, 4. Here, 1 times 3, 3. 2 plus 3, 3 plus 4, the beta 10, 7. Okay, you need to have a fraction. The denominator is always 2. Let's معناها in total we have 7 oxygens there. 7 minus. Let's معناها 1. 7 minus 1 equals to 6 over 2 equals to 3. Put this to here. Another one. They back. Another one. Another one. Bonumna. C2H6. They plus what? O2. To form CO2 plus by H2O. Balance. Carbon is 2, here is 1. Multiply this by 2. There. Hydrogen is 6 hydrogens are there. Here we have 6 hydrogens, but here 2. Times this by 3. Then take the total oxygens here. 2 times 2, 4 plus 1 times 3, 3. 3 plus 4 equals to 7. Good. So we have 7 oxygens right the right side. Good. The combustible substance, it has 0 oxygen. Have a fraction. The denominator is 2. 7 minus 0. Our oxygenated. Try to subtract this by this, please. Equals to 7 over 2. Put this to here. Is this okay to have a decimal number as a coefficient for the combustion reaction? Yeah. Because the point is we need to have 1 mole of the substance that has been combusted under the presence of enough amount of oxygen. Therefore, it's okay to have a coefficient of oxygen by decimal number. Only here, please. Okay? So that's how you can write the combustion reaction. Let's learn the definition of the combustion reaction, and then we'll stop right there. Look, enthalpy of combustion is symbolized by delta Hc. Is the enthalpy change? Delta Hc is delta H. Again, يعني ما وصل delta Hc delta H equal them. When 1 mole of the substance has been combusted, or during the complete combustion of 1 mole of the substance can be element or compound. Good. Tamam? Seyrweka. How to write the combustion reaction, how to balance. I have explained the whole thing is here. So these are called combustion reaction. How do we know if the reaction is a combustion reaction? Okay, mister? We need to have 1 mole of the reactant plus by O2. 1 mole of the reactant plus by O2. 1 mole plus by O2. In all of these equations, delta Hc equals to delta H. So what is delta Hc? Delta Hc, it stands for the enthalpy of combustion. What? If somebody asked you explain delta Hc in a simplest way, okay, just say delta Hc is the enthalpy change. Look, enthalpy combustion. What is enthalpy of combustion? That is delta H is a delta H when 1 mole of the substance is combusted. That's all. Done. So look at it. On what basis are enthalpies of formation? Look. On what basis are enthalpy of formation and combustion have been explained? Okay, look at this. For the formation, we will say 1 mole of the substance at the product side, but for the combustion, 1 mole of the substance at the reactant side. Then, inshallah, next lesson, I'm going to explain how to solve math problem questions or how to calculate the enthalpy, the value of delta H. So, بدلنیاییەوە پرسیاری خۆی لێ دێتەوە لەو زاری ئەوڕۆ باسی دوو ریاکشنم کرد formation و combustion. دڵنیات دەکەمەوە بەبێ formation و combustion you will lose half of chapter 4. With them you will gain the whole thing is in chapter 4. والله گەلە ئاسانیشە تخوا یعنی 1-2 ڤیدیۆکەی تەماشا بۆ خۆ دنیا خرانابی بابی من. Okay, inshallah زۆر باش دەبی. Believe me, this is nothing compared to your brain. You have a very nice, strong brain. Wallah, you can do anything. But the point is, you need to have a goal. you need to have a hard working place. You have to work for your goal. ئینشاءالله بە دڵخۆشیتان بیرمەوە بە سەرکەوتوی هیوام وایە چی باشە ئەوە بێتە ڕێتان ئینشاءالله تاوانێ داهاتوو بەخواتان دەسپێرم خواتان